A little bit about me. My name's Matthew Hodgkins. I work as team lead of developer efficiency at a company called Datadog. What we focus on there is how to make developers' lives easier during their development process. So some of the stuff I'll be showing you today is some stuff we use. Can I have it on the stand? I've just got a demo.
I'll just bring it.
Yeah, okay, awesome. Some of the stuff I'll be showing you today is based on the work we do at the company. So I'll dive into the agenda. I'll be talking about the inner loop, so the development flow of the inner loop, some potential workflows for developing on Kubernetes, a tool called Tilt that can help us enable these Kubernetes workflows, and I'll go into a demo of Tilt. So what is this inner loop that developers are doing? So pretty much it's all the stuff they're doing before they share their code with the rest of the world. So pretty much they're writing code, they're doing a build, they're getting feedback to see what's happening with the feature that they're building, and they're doing this process over and over and over again, like thousands of times before they do a commit or push their code to the rest of the world. And this cycle is just about experimentation and then feedback. And we want to be making this loop as fast as possible. So, and we also want to focus on the quality of the feedback that they're getting. So our job is to make this loop as quick as possible. So there's a couple of things that can kill the speed of this development loop that developers are going through. So the first one is build speed. So Go is pretty good at build speed. It's really quick to compile Go, so it's a good tool for it. Another one is being able to validate things locally. So if you've got a super complicated build and you're having to push to CI to have a Docker container built, you can't do that on your laptop, that's really going to slow down this developer speed, and you're going to have really long cycle time. If you have like an app that has lots of complicated dependencies, maybe you're working with several data stores from a certain application and you're having to set all this up on your laptop, you've got like 20 Docker containers running locally, a million databases that you have to stand up, and you're doing a lot of this manually. Like Docker Compose helps, but there's a lot of toil that goes into trying to set up this environment locally for a developer. There's some things that kill the quality of the feedback that the developer's getting as well. So some things is like running something on your Mac, running Go on your Mac is a lot different than running in a Docker container, in AWS, in Kubernetes like you would be in production. So the runtime is going to be a little bit different. You might also have different dependencies as well. So say you're working with these data stores locally, you've just pulled like a MySQL container down from Docker Hub, and you're working against that as you're developing locally. When you push to staging or to production, you're going to have a different data store. Maybe you're using RDS, and it's going to have different behavioral patterns or different versions. Things are going to be different. So the quality of this feedback that they're getting locally is not as good as it could be if you're developing against those services. And you might even have dependencies you can't access. Like we saw an example before about emails. So a lot of times you're not allowed to access email servers from your developer laptop. There's certain services that can only be accessed from your staging environment or your production environment. So if you're trying to develop things locally, it's difficult to access some of these dependencies sometimes. So let's have a think about how Kubernetes might be able to help improve this quality by getting us developing things a lot closer to they could be in production. So if we think about like the container image, so we can build a container locally, we can push that to Kubernetes, it can run it in exactly the same way as we would be if we're running in production, when we do that locally. The runtime is going to be the same. So our Kubernetes cluster, if we can develop against that in AWS, say, it's going to be very, very similar to what it's like running in production as opposed to running Docker locally. You might have some interesting like networking or firewall rules set up. So like from a developer's laptop, you can't access certain things that the staging environment can access. But if you're developing on a Kubernetes cluster in that environment, you will have access to all those things. And you could also use the same resources. So say you have an ops team or a database team that provides you like a Helm chart, which is how they configure like a MySQL database for production usage. You can use that as well. You can leverage all the tools that they're already doing and use it in your development process inside Kubernetes. Say you've got supportive services, like you've got metrics and logging, you're using a nice tool like Datadog, for instance, hooked up to your staging cluster. Maybe you've got like Elasticsearch or something like that. It's very difficult to get that whole setup and that whole flow working on your local laptop, but that's already going to be set up in your Kubernetes clusters that you could potentially use as part of your development process. Maybe you've got some cloud resources that you want to access, like an S3 bucket that you want to use when you're developing. And that's very difficult to access locally. You have to set up IAM permissions or something like that. It's very difficult to get that working locally, but it's super easy if it's running in the cluster. So it would be pretty interesting if we could develop against Kubernetes. But what would this inner loop, what would the development flow look like if we were doing this? We'd pretty much have to change some code locally. Then we'd have to build the container locally. We'd have to push the container to the image registry that the Kubernetes cluster can pull from. Then we have to update our Kubernetes deployment to pull that new image that we've just pushed. And then we're going to have to run some Kubernetes, like kubectl commands to get logs and figure out, if it's running or something like that. So our inner loop cycle is going to blow out quite substantially if we go with this sort of workflow. So let's see how we can address some of these things. So there's always this dichotomy between the quality of the feedback you can get and the speed that you can get it at. Like it's super quick to do stuff locally, but the quality of the feedback isn't as good. So let's first have a look at this at build speed and how we can improve that. So this is a pretty standard Docker file for building a Go binary. Let's have a look at some of the optimizations we have in here. So first of all, does anyone know what this does and how this can help us speed up our builds? Nope. So this is pretty much tells Go to pull its dependencies from a Go proxy, which like Google is running pretty much, and it's about 6 times quicker to pull dependencies from that proxy than it is just pulling off GitHub. So that's already a 6 times speed boost in just pulling dependencies in just one environment variable. What about this one? Does anyone know what this is doing to speed up your Docker builds? Nope. Okay, so this one is pretty much we're adding the Go mod and Go sub, the Go sum file. So if you're using like Go modules, and then after we add those into the container, then we're doing a Go mod download to download all our dependencies. And because the way Docker does its layers, it's going to be all cached. So if we're not changing our dependencies, we're never going to have to pull those dependencies again. They're going to be stored in that layer. So that's really going to speed up our builds. Does anyone know what this one does here? A bit hard to see. Yep, exactly. So pretty much what we're doing is a multi-stage build here. So we're building our Go binary in this top container up here, and then we're copying it into this really small Alpine container. So it's going to be a lot smaller than this builder container we have up here. Do you know what the performance impact of doing this is compared to building the Go binary inside this first container? Do you know where we're going to lose performance? So pretty much what Go is doing in this step here is it's building out a build cache, pretty much. So it doesn't have to compile everything, every function, every bit of code over and over again. And what we're doing when we're copying that binary out to this other layer, we're pretty much throwing away the builder container layers here. So we're losing all that Go cache. So this is actually going to slow down our build by a couple of seconds. So we'll have a look at how we can address that soon as well. And for the rest of the stuff, so this inner loop against Kubernetes, we're going to have a look at a tool called Tilt. And what this is, it's a little tool that allows you to quickly develop services against Kubernetes. So it has a couple of features to let you do that. The first one is it's going to watch files on your file system, and when it notices changes, it can trigger builds for you automatically, or it can just suggest that you trigger a build. And then it will handle pushing these container images that you're building locally into the registry. It'll handle automatically updating the Kubernetes deployment and switching over to the new container that you've just pushed. And then we can do some tricks with live syncing. So instead of building a whole container, we can just build a Go binary locally and stick it straight into a running container and get the build and the cycle time down to just a couple of seconds. The other nice thing is it has a nice web UI, so it's really easy for people that haven't used Kubernetes before. They don't have to touch kubectl, they don't have to dig around in Kubernetes. It's a really nice interface for them to use. It's got a couple of requirements. They're very minimal. The first one is the tilt binary is installed. It's built in Go, so it's just a tiny binary. You can just stick it on your Mac. You need a Kubernetes cluster to connect to. So tilt can do this workflow. You need a container registry to push to. What I would recommend is building these Kubernetes clusters like in your cloud environment next to where your other clusters are. That's how we do it at Datadog, just to keep it as close as possible to what it's going to be like in production. What I'm doing here for this demo is using a thing called Kind, which is called Kubernetes in Docker. It's pretty much just running a Kubernetes cluster on my MacBook. But yeah, I wouldn't really recommend, you're not going to get as much value doing this as you are building against a remote Kubernetes cluster. So let's dive into the demo. So what we have here, this is the folder structure. So we have this apps folder. We have this intake service, which is just a super simple HTTP service here. We've got our main.go. We've got our Docker file that I showed you just before. And we have some Kubernetes resources for it here. So we have this deployment, which is pretty much just using the container super simple deployment and a super simple service. We also have this tilt file down here, and this is just a configuration file for how tilt is going to operate. And it looks very Python-y. It's using a thing called Starlark, which is like a small subset of Python, but allows you to write sort of functions inside your configuration language. So it's way better than YAML, way better than a lot of other configuration languages, because you can just write functions in there. So we'll run through this. So we've got a Kubernetes namespace defined. So this is a namespace I want to be created when I operate with Tilt. I'm telling it to allow this Kubernetes context, which is just my local Kubernetes in Docker, but this is sort of giving you protection so you don't have your Kubernetes context connected to production and then just start hacking away on production. You have to be pretty explicit about that. And then we're loading up, over in here we have this Tilt Kubernetes, and we just have this super basic Helm chart here, which is just to create a namespace, just so I'm separated from other developers, pretty much. We're calling this function which Tilt provides called Helm, and which we pass in the directory where that Helm chart is. Then we pass it to this function called K8's YAML, and Tilt's going to be able to know how to handle that and how to deploy that. So that's all we pretty much need. And down the bottom, I'm just calling the create namespace function that I've created. So I'll go into my directory and I'll do a tilt up, and immediately Tilt's going to start. It's got a CLI interface as well as this web UI interface. You see this uncategorized section down here? You can see this is the chart that's just applied to the Kubernetes cluster. So if we have a look, get all the namespaces. We can see my namespace was just created as I stood that up. So the next thing we want to do is get our Go service running inside the cluster. So this is it here. So again, we're just using the K8's YAML. We're passing that Helm chart I showed you before. And this time we're adding a little bit more functionality here and pretty much saying, I want this port forwarded. So from that service that's running in that application, I want it port forwarded localhost on my machine so I can access it. And then we're telling Tilt how to actually build this service locally. So you can see this is the name of the container that I'm going to build. This is the command line function it's going to call to actually build this. So I'm literally just going into a directory and running a Docker build. And then Tilt's giving me this expected ref, which is what's the Docker tag that Tilt wants you to build the container image with so it can control it. We're telling it some dependencies here, so like on the Docker file, and I'll explain this a little bit more later. And pretty much that's it. I just tell it that, save, and if I go back to Tilt, you see it applying. And you can see Tilt's watching these files, so it's watching the Tilt file for changes, and automatically it'll just reload and start applying this. And you can see here, if we scroll up a bit, it's done the whole Docker build for me. It was very quick because I've got it cached locally. It's pushed it into the cluster, and then it's applied the Kubernetes resources. So if we have a look over here, okay, good. So we can see a couple of seconds ago, my pod's been deployed into the cluster. So let's go and make a change and see what happens. I'll show you what the service actually looks like. So I'm not a very good Go developer, so I've got a super simple endpoint up here. We can hit it with this. I can just send it sort of JSON requests, and it's, if we switch back over here, you can see some logs. These are Kubernetes logs being streamed out, so I don't have to know the command to see the logs from Kubernetes. You can see everything streaming to the application there. So now let's change some code and just do a normal Docker build and see what happens. So go here, change some code. And save that. And then I'm just going to trigger a Docker build. And this is where we don't have any cache here, so it's going to take a couple of seconds to actually build the binary. Put it into that layer. So it's finished, it's pushing. And now my service is up and running. If I refresh this, I can see the code that I've just changed, and it's running inside the Kubernetes cluster in a matter of seconds. But we can get that to be a bit faster. So if we go back to the Tilt file, we see this local resource. And what we're going to do here pretty much is build the Go binary locally, so outside of the container, and then tell Tilt to watch a folder. And when it sees the binary come into that folder, we're going to, this is the folder we're watching, and we're going to tell it sync that into the running container in this directory. And then we have this little script which is holding PID1 inside the container so it doesn't crash pretty much when we stop the service. And we're going to live sync that binary in. So this is the command that I'm running locally, and all this is doing is pretty much a normal Go build, and it's just dropping it into a specific folder. So if we enable this live update functionality, save that. So you can see it pops up in the interface here. Let's go and make another code change. Save that. And you can see Tilt's noticed how it's watching all the Go files, so it knows this thing needs to be rebuilt. So I click that. And this is going to do, it's going to run this command, which is going to do the Go build locally. And you can see, you might have missed it there, but it already updated the container. So if we refresh that, it's already there. So we'll go and make another change. Save that. Reload. And it's already running. So in about 3 or 4 seconds, your local Go code change is running inside the Kubernetes cluster. So this cycle time is really, really slow. Oh, quite fast, sorry. The next thing I'm going to do is, say I want to write to a database. I want to use a database, and my ops team provides some Helm charts for how they're running their databases in production. So I'm going to uncomment this one. So it starts, pretty much it's super simple here. This is the directory where those charts are. I want the name of it to be MySQL, and then I'm doing another port forward, and pretty much those charts are just living in this directory here. If I go back to Tilt, you can see it's starting to provision this up. And while that's going, I'm going to load these workflows as well. I'll explain those in a minute. Takes a little minute for MySQL to load, but this is much easier than having to figure out how to run all those Docker commands and build a Docker Compose file. It's all provided by the ops team. This one is literally just downloaded off the Helm hub, downloaded it, dropped it in the directory, and I have a running MySQL service in a couple of seconds. Still waiting for it to come ready. And this not only works with Go, you can use any sort of language. Pretty much all Tilt needs to know is how to build the container and how to copy files in, and you can use it with any language. So we have 3 main languages that we use, like Python, Go, and Java. All of them can work fine in this framework. So you can see MySQL's coming up now, and I can go into my IDE here, go to the database, and inside the database, inside the IDE, I can just refresh, make sure I can connect to the database. And we can see there's nothing inside the database now, but I'm connected. I've got a database that I can access. And now, say I want to run some migrations. I'm a developer. I don't care how the database gets into the state. I just want a working database. So we have these things over here, these Kubernetes jobs. These 2 jobs. So pretty much like a DB migrate job. So pretty much all this is a MySQL container with a schema inside it. So this is the schema, super simple stuff, just create a table. And I can click on migrate. It's going to apply that. And then if I refresh over here, you can see I've got my table that's been created. And then I want to change my Go code to actually write these queries into the database. So I can go back here. No screen real estate. Yeah. Here. So uncomment this function, and all this is doing is just going to write those web requests into the database. I'll do a rebuild. Now when I send some requests, back here. Resolution is difficult. There we go, we can see those requests that have just been added to the database. Say I make a mistake, well, how do I reset my database? Well, we can use those Kubernetes jobs again. We just have that database drop. Click on that. And come back here and refresh. So the table's gone. I just run migrate again. My table's back. So you think we saw the demo before and about testing and looking for this command in the make file. And when you get really complex products with millions of line make files or rake files, it can be quite complicated to find out what's the actual thing that I need to do. Everything's listed just in the UI here, like super simple to find all the things you need to do in just a matter of seconds. So really handy for people new to working on projects as well. That's it for the demo. So let's wrap this up. So pretty much we talked about the inner loop. So this workflow developers are constantly going through to get value to customers. Really, they want this really quick, really quality feedback cycle. We talked about how we could potentially use Kubernetes to increase the quality of the feedback they're getting by developing on something that's very close to production. And then using Tilt to sort of keep up this high speed even though we're increasing the quality. So we didn't lose any speed doing this, we just increased a hell of a lot of quality for losing not a lot. And you can see how Tilt can be super easy for developer onboarding. So literally all I had to do was, I'm a new developer, I clone the repo, I cd into the directory, I type Tilt up, and there's the whole way I can use all the databases, build the tools, see all the logs. I don't have to know anything about anything, and I can still develop on my services. So a super nice way for new engineers to start working on your code base. So. There's some resources here. Tilt.dev is where you can go and see all the documentation for Tilt and learn how it works. I've got this repo here which has all the code I just showed you and all the Tilt files, so you can go and experiment on your own laptop. And that's it. Any questions at all?